Yes, class. Good evening. Am I audible to all of you?
Good evening, ma'am. Yes, ma'am.
So who all are here right now? Hania, Khalid, Salman, Sumaira, Said. Okay, all of us. Fine. So in the last class, we had started with alternating current, where we had covered the principles of AC generator. So AC generator is basically a device that converts the mechanical form of energy into electrical form. And it is based on the whole electromagnetic induction that you have studied. I think I've sent your marks now of EMI, electromagnetic induction. I think I've just sent your marks. Just remind me once in the middle of the class to show your papers. I'll just scroll once so that if any queries there, that can get through. So Faraday's laws of EMI you are aware of, that whenever magnetic flux changes, then EMF is induced in it. And this second part of this Faraday's law is that EMF is directly proportional to rate of magnetic flux. Similar thing we had observed in case of this AC dynamo. If flux is BA cos omega t, why? Because theta is omega t. So EMF will become BA omega sin omega t. So these were certain things. AC dynamo was at least clear by that time. Now what happens is that the next topic that you have is the average value of AC. Alternating current, what's the average value of AC? So that we'll discuss average value of AC. Now there are two things. One is one complete cycle, the other quantity is half cycle. Complete cycle means what? The rotation has occurred completely. So whole time period we'll consider. And when the time period reduces to half of its value, that becomes what? Average value of AC for half cycle. So first let's see average value of AC for full cycle. And these two questions are asked in the exam. In the previous years, I have seen these questions coming to prove full AC and half cycle. From here, from these two topics, average value of AC for full and half cycles, more than numericals, this derivation comes. So try to focus on the derivation part in this, at least, for full cycle. Now, one thing you have to remember, other part will be clear. C class, whenever you have the value of current with you, see, this can be done in different method. This can be done by different methods. We'll solve it by current. If I say current is what? Current is I naught sine omega t. Did we discuss this? Why do we write I naught or E naught? The last class, did we discuss the peak value? No. See, in these equations, no. Whenever E is written, E is equal to E naught sine omega t. This E naught means this, or I naught, this means the maximum value. Or you can say the peak value. Similarly, for E naught will also become the maximum value of EMF or the peak value of EMF. Now this is what? This is like in DC current, you had the current I naught, suppose. So in alternating current, how will you have the exact value of current? Obviously, the value of current will also get changed. So if it is I naught for DC, for alternating current, that is I prime, it will become somewhat sine omega t multiplied by I naught. Then only no value will get changed. That's why we write it in this form. And the fact that the current and the EMF vary sinusoidally, that's why we write it in this way. So alternating current at any time instant t, any instant is given by I is equal to I naught sine omega t. So assuming the current remains constant for a small time, that is dt, let's say, the amount of charge that will flow. Charge will be what? Current multiplied by time, I dt. This makes it I naught sine omega t dt. Now charge will be what? We'll integrate both the sides to find out the complete charge. This becomes I naught sine omega t dt. Now the time limits. What did I tell you? This is the complete cycle. Complete cycle means full, complete rotation is there. And again, class, I'm telling you, this proof question definitely comes in the exam. This question, more than the numerical part, from this topic in alternating current in this lesson, chapter 7, derivation, these two derivations, and that these two derivations are important. From RMS part, the questions come. So this complete charge will be what? Let's say complete charge is Q. Integration from 0 to capital T. Capital T is the total time that we are taking. Dt was a small time instant. Capital T is the total time. So it becomes I naught sine omega t dt, integrating it from 0 to capital T. From here you can begin your derivation. Now class, I naught is a constant, so I naught will come out. I naught is a constant, so this I naught will come out. Now what will happen? When this I naught came out, what is left? Sine omega dt integration from 0 to t is left. Class, whenever you're finding the integration of sine, this becomes what? This becomes minus of cos theta. That becomes minus cos omega t. But remember in differentiation, I told you omega comes out. If it is sine omega t, then that becomes omega cos omega t. In differentiation, this omega gets divided. In differentiation, this omega gets multiplied. In integration, this omega gets divided. This you must have studied in your mathematics class. For all those who have it. So for this is from 0 to 2. So Q becomes I naught divided by minus I naught by omega. What is left? Cos omega t from 0 to t time period is left. Now class. Minus I naught by omega. What is this? This is cos omega capital T minus cos omega into 0 you can write, or you can directly write it as 0 also, cos 0 degree. T is equal to 2 pi by omega. Remember this relation. So this will become what? Minus I naught by omega. Cos, instead of time, you can write it as 2 pi by omega, or you can write omega as 2 pi by 2. Minus cos 0 degree. So this becomes what? Minus I naught omega. See, cos 2 pi. Cos 2 pi is what? 1. Cos 0 degree, this is also 1. What's the final answer that came? 0. So value of alternating current is also 0. Value of average EMF, this will also be 0 for, this is valid when these brackets, so these represent average value. These are valid when? For for a complete full cycle. So if the question comes, directly write it as that average value of EMF or average value of AC over a complete cycle is 0. This value over a complete cycle is 0. The same thing. So question comes, prove mathematically that the average value of alternating current over one complete cycle is 0. So you have to show these steps. This question comes. Another method to prove is that by taking the average EMF. Both the methods are fine. I think you should just note down this method. That is sufficient. Then we'll see it for half cycle. First note it down here. Any queries, ask me meanwhile.
Ma'am, by the way, what is that bracket like thing around I?
That shows average. See, whenever you write no average EMF, so instead of writing, you can write it as this way also, E average, or any quantity. If you write these brackets, this shows that you are taking the average of these quantities. So every time writing average value of AC, average value of alternating current, it's not possible. So we denoted by this. This is the average value. And time denotes that whether it's for full cycle or half cycle. Clear, Khalid?
Yes, teacher.
C class, if it's the case of half cycle, no, if we are calculating half cycle, there will be a very slight change in the calculation. If we are calculating this for half cycle, the fact that made it unique for a complete cycle was the fact that the time period was from 0 to capital T. Now the time period will be 0 to T by 2. It's just the half cycle. Half cycle means what? Full cycle means what? It's like this is one complete rotation of the EMF coil, let's say, or the AC dynamo. So one complete rotation, this becomes time period. So that was what we were trying to find out. What will happen? What did you study? Magnetic flux you had studied. So in case of magnetic flux, what happened? You had an angle, the area vector that was making with the magnetic field. This angle you used to consider. So if this angle changes, if this angle is variable, what will happen? Value of EMF, value of I current will keep on changing, but you require a specific value. It's like drift velocity. What did we study? Every electron possessed a different velocity. So when we wanted to calculate the average velocity, or we wanted to calculate the velocity that was flowing through a wire, what did we do? We calculated the average of it. That's what we are trying to do. At every angle, the value will keep on changing like this. This will keep on changing because of the change in angle. So we calculated the average of it. So average for the full cycle is 0 to T, and for the half cycle, from the initial point to the half cycle, that will be simply T by 2. So here the difference that will come will be T by 2. But your answer will definitely get varied. This is integration is from T by 2, T by 2. C class. The change in the answer that will come. Till here, this will remain the same. T by 2 will come. So what will happen? Charge will be what? Minus I naught. Let's write omega as 2 pi divided by T. Let's write it as 2 pi by T. This is what? This is cos 2 pi by T into T by 2 minus 1. So 2 cancelled, this became T cancelled, cos pi. What is cos pi class? What's cos pi?
Minus 1.
Minus 1, exactly. That's minus 1. So here you had minus I naught capital T. Here you had minus I naught capital T divided by 2 pi. You have over here what? Minus 1, minus 1. So this time for a half cycle, your answer won't come out to be 0. So average over a complete cycle, it's 0. Yes, over a complete cycle, it's 0. But for half cycle. So this becomes what? Minus I naught. Charge will be minus I naught T divided, T. Divided by 2 pi into minus 2. So 2 gets cancelled. This becomes I naught. So minus 2, no, minus 2 minus 1 plus pi. This much. Now what will be current? Current here will be charge divided by time. That becomes I naught. Again, I'm writing it as I naught T pi divided by pi into T. T gets cancelled. This is the value that you're getting. I naught divided by pi. So anyone remembers the value of 1 by pi? Value of 1 by pi. One more thing, class. See, 2 will also come over here. This is what? This is actually, if you see over here, this time period will not be only q by t here. 2 will also be here. So t divided by 2, because we are finding out what? Over a half cycle. So we will not neglect this 2. So 2 will also come. Fine. So 2 I naught by pi, if you write till that also point, it's right. Or if you wish, you can further write this I as 0.6037. This becomes what? 0.637 I naught. Similarly, value of current, this will be what? This value of current is 0.637 I naught. Similarly, value of EMF will be 0.637 E. This way. So this is just the change that will come. So entire derivation till here it will be the same, just the power will get changed. Not the power, the limits will be changed. Done? Others also, apart from Hania and Samaira? Before we move on to phase and phasors, no, one more topic is there, that is RMS value. This is important. This is very important. This is important in the sense the derivation also comes to what is meant by RMS value or effective value of an alternating current, and to derive the relation between its peak value and its normal value. This question also comes. Apart from it, normal numerical values also comes to solve the questions. So let's see, root mean square. RMS basically means root, M means mean, S means square. So root means square, or we can also call it as virtual. Virtual value of AC or effective value of AC, all these names are applicable. Virtual values of AC. So RMS is root mean square. Now, it looks like we are first calculating the root, then we are finding out the mean, and then we are squaring the answer. But in reality, we first take the square, we then take out the mean, and then we calculate, we put it under a root sign. Remember, just go opposite. So square, you people know how to calculate normal square value. If I is the current, then square will be what? I square. Now, one thing, class, how to calculate the mean value. This is very important. With the help of this, no, last question can also be derived. But never mind, you can solve the last numerical by the charge method also. Mean value can be calculated by any, if it is EMF or if it is current. Take whatever is the value. Right now we have I square. Integrate it from whatever is the time given, 0 to t, divided by the integration of total time that is given. This is how, just remember this, rote learn this even if it's possible for you. Because no need of derivation, and this doesn't get utilized anywhere else. This is just restricted to this lesson. Nowhere else you will use this concept for calculation of mean. So that's why it's better, instead of deriving and proving it, if you remember this, whatever quantity is given. In the last question also, no, in the last, this thing that we had calculated. Yeah, see, this could also be calculated for the average value of EMF. It could be integration of EMF dt for full cycle 0 to t, integration dt from 0 to t, half cycle t by 2 t by 2. Like this also you can derive the entire thing and get the value as 0 for full cycle and exactly whatever is the value for the half cycle. You can do that derivation also. Just check in your school how it is done. Now, square is done, current was I. So first step, square. Second step, mean. Third step is just put under root. That becomes I square dt 0 to t divided by integration of dt 0 to t. This is what you have to do. So I effective, I RMS, I virtual, whatever you have to call it by, whichever name, I RMS, by any name you can call it. This will be equal to what? This will be equal to root. This is the mean. Root mean square. IRMS. RMS, root mean square. Right? Now see, if you look at the denominator part, can anyone answer without solving? What will be the denominator? Without solving even. Integration of dt from 0 to capital T. Nobody can solve this orally. Most of you have mathematics even. And even if you do not have, we have done this. This is the basic integration. Integration of dt from 0 to t. What will be the answer? All of you reply me in the chat box. Yes, Zed?
Ma'am, T.
Exactly. It will be capital T. Integration of dt is what? It's just t. Limits from 0 to t, that becomes t minus 0, which is t. All of you forgotten your basic integration. So what is left? This is right. Capital T will be here. Over here you will have capital T. Fine, class. Just have capital T over it. Now if you look at this term, if you just look at this term, let's just not solve the whole bracket at once. Otherwise it will become very confusing. Let's just solve this term first. I square dt. Integration of I square dt from 0 to t, because this term is capital T. Let's solve this term also. Now when we'll put it at the end, that will make our work easier. So see, I square is what? I was equal to I naught sine omega t in AC, alternating current. This was direct current. So this becomes I naught square sine square omega t dt, integrating it from 0 to capital T. So I naught square will be the constant that will come out. Now sine square omega t, remember class, sine square omega t, when you are integrating it, this becomes 1 minus cos 2 omega t divided by 2. So this will also be 1 minus cos 2. This will also be 1 minus cos 2 omega t divided by 2, integrating it from 0 to t dt. Fine, class? Now what you can do, dt, now just solving of integration is there. Bring this 2 out. I naught square divided by 2. Keep it like this, I naught square divided by 2. Integration 1 is there, so that will be t only, minus integration of cos will give you sine, so with a positive sign. Already it's a negative sign here, so we need not write one more negative sign. That becomes sine 2 omega t divided by what? Not the whole term, just this term. Divided by, what's the constant? Constant over here is 2 omega. Yes, right. It will be 2 omega. And limits will be from 0 to capital T. When it was omega, so we divided by omega. Here it became 2 omega, so we'll divide it by 2 omega. If square comes in, respectively, corresponding to that, we'll write. So I naught square divided by 2, leave it. This is what? T 0 to t, that will be simply t. This becomes what? This will be C, sine 2 omega t divided by 2 omega. You can do one thing, minus 1 by omega. Instead of writing omega in the denominator, in the numerator. See, do one thing. This is there. This we have taken it. Minus 1 by 2 omega is here. What is left? Sine 2 omega t is left. That you can directly write it as sine 4 pi by t. Because omega is what? Omega is ultimately 2 pi divided by t. So 2 pi by t got multiplied by this 2 became 4 pi by t. This is what is left. And these are having the limits from 0 to capital T. This is what is left. Now I naught square divided by 2, t minus 1 by 2 omega sine. So this will be, firstly it will be t. So tt will get cancelled. This becomes 4 pi minus, second time this will become 0. Lower limit will also be kept. That becomes sine 0. See the final answer. Not the final answer. We are just solved this part. So this will be t. See, this becomes 0. This term becomes 0. So here we are just left with Sine 4 pi is 0. Exactly. That sine 0 is also 0. Sine 4 pi is also 0. So we are just left with t minus 1 by 2, or we are just left with 0. Why to write this also? Why to show that this is getting multiplied with? These are 0. So this becomes simply what? This becomes t only. So what did we solve? We have solved this. Just this part. Ye wala. This we have solved this. And this is what? This comes out to be I square t by 2. That's what we have seen. And this is just capital T. See what is left, class. In this main formula that we had, under root I square dt from 0 to t divided by integration of dt from 0 to t. This part comes out to be I naught square t divided by 2. And this part comes out. So what will be IRMS? Under root I naught square t divided by 2 divided by this t. Dt gets cancelled. IRMS comes out to be I naught divided by root 2. Similarly, if you perform the same derivation, whatever is ours, just change the value. ERMS will be E naught divided by 2. This is the value, or you can even write 0.707. IRMS will be equal to 0. Because 1 by root 2 is what? 1 by 1.414, and that is equal to 0.707. And ERMS will be 0.707 E. Dear class, so it can happen that you may find any doubts in this, especially this part. So if you have any doubts while writing, that time only ask me. Otherwise, it will get piled up. This much, Anya?
Yes, ma'am. Ma'am, you can scroll down.
C class in this question. What is the instantaneous value of EMF that is given? 140 sine 300 t. This is given. What was the main equation? E is equal to E naught sine omega t. So without calculation, can you tell me what is the peak value from this equation?
140.
140. Yes, Samaya. Perfect. Because E naught is the peak value. And here, this is 140. So answer for the first part, this will be simply E naught will equal to 140 volts. Second part says the RMS value. We have derived a relation between the RMS value and the peak value. RMS value is what? Peak value divided by root 2. So this will become 140 divided by root 2 volts. You can solve this. Solving this is easier. See, 140 divided by 1.4, if you say 1.4, 1. So that will be simply 100, around 100 it will be. Last part is frequency. Again, look at both these equations, compare. What is the angular frequency?
300.
300, exactly. This is 300. So if omega is 300, you can easily find out. So that will be 50 hertz, correct, sir. That will be 50 hertz because frequency is what? Omega by 2 pi. So omega is 300 divided by 2 pi. So that becomes what? This will be 3.4 something. C class, this will be around 3.14 something pi's value. So that will be, if you round it off to 3, that will be 100, approximately it will be 100 by 2. That will be 50 hertz. Right, class, note down the question and the solution, then we'll do something else. All right. So this was about the average AC, instantaneous AC, RMS value of AC, and not only AC, alternating EMF as well. This was alternating EMF only. Now the next topic that you have are the phasors. And this is the basis for your upcoming circuits. AC circuits are there in your syllabus. You have AC circuit that has only resistor. You have AC circuit that has only inductor. You have AC circuits that have only capacitor. All these you have studied. Capacitors and all these you have studied separately. Capacitor you have separately. Resistor you have separately. Now see what is the meaning of phase and phasors. See, a phase is basically rotating vector. Any vector that is varying sinusoidally, no, that is known as a phasor. I'll write down the definition also of the phasor. There's a very slight chance that the definition of phasor can be asked. It actually came once, the definition of phasor, in your CBSE exam. So definition of phasor coming is not unique, but you should remember it's what? It's basically a rotating vector. A rotating vector that represents a sinusoidally varying quantity. This is called as a phase. It's a rotating vector that represents sinusoid. So this vector is imagined to rotate with angular velocity, which is equal to angular frequency of that quantity. And length represents the amplitude of the quantity, and its projection upon a fixed axis gives the instantaneous value of the quantity. What is meant by what I've said? Just see, before that, understand what is a phasor diagram. Then I'll tell you what is the relation between phasor and phasor diagram. So this is phasor diagrams. So phasor diagrams, no, they represent alternating current or voltage. I'll keep on writing the definition simultaneously. It's a diagram that represents alternating current and voltage, EMF and AC, alternating current and alternating voltage. So with the help of a diagram, basically a graphical diagram will be used later on, but phasor diagrams are basically, they are represented in a circular form, circle and arrows represent, but frequency should be seen of same frequency as rotating vectors. Rotating vectors means what? Phasors. So along there has to be a proper phase angle between them. This is what is known as a phasor diagram. So along with a proper phase angle. This is known as phasor diagrams, and these are also known as Argand diagrams. But phasor diagrams are common to use. So just understand phasor diagram. Now, what is actually meant by this? This was all theoretical. See, I'll tell you. Now, in case of phasors, what happened? We have the y-axis and the x-axis. we draw it in the form of a circle only because it helps in the simplification of the study. So one quantity, let's say EMF is over here. Other arrow, this will represent current. Let's say peak values of both of these, and with which these are rotating, that is angular frequency, and these are phasors. So phase, and this whole diagram, this becomes the phasor diagram. Fine. There is an angle between them. This angle can be phi naught or phi, any angle you can choose. Its maximum value is what? Maximum value is E naught. Like this we draw it. This is the general form. Now we'll come to one of the circuits, each of the circuits. Then you will understand how to actually use these phasor diagrams or draw it in the form of graph. First circuit, let us just complete first circuit, that is your AC circuit containing only resistor. AC circuit containing only resistor. AC circuit containing only resistor. It means a resistor is there, is connected to the variable coil. Now battery is not connected. C class, this is the source of EMF. This is the source of AC, whose value is E naught sine omega t. This is the resistor R. This we know. Okay? So this is AC circuit containing resistance only. So E is equal to, here E is equal to what? Here E is equal to E naught sine omega t. E is equal to E naught sine omega t. Fine. So suppose a resistor of resistance capital R is connected to a source of alternating EMF. This is given by E naught sine omega t. And this circuit is known as a purely resistive circuit. See, when we'll do combinations, no, right now we are doing individual circuits, only resistor, only inductor, only capacitor. When you will combine inductor, resistor, capacitor, all these, there you will see purely capacitive circuit and purely inductive circuit. What is the significance? Right now, just understand, such a circuit is known as a purely resistive circuit. Now, instantaneous EMF will be equal to what? Instantaneous potential difference across resistance. Means if you use V is equal to IR in terms of instantaneous value, instantaneous EMF, instantaneous current and all. So instantaneous EMF is E is equal to E naught sine omega t. Current, let's say current is I. The resistance is R. From here, current becomes what? Current becomes E naught sine omega t, this divided by R. So class, remember right now we have concluded this. I was equal to I naught sine omega t. So if I naught is this, and here I naught instead of I naught, this is E naught by R. So what's the value of I naught? I naught for purely resistive circuit is E naught divided by the resistance. Now coming to phase and phasor concept. First, let us understand with the help of graph. The fact, some points you have to remember for all the circuits. You have to remember that for purely resistive circuit, current and EMF, both the phasors, both these phasors are in the same phase. There is no phase difference between them in case of resistor. What is meant by this? Neither current is leading nor EMF is leading. Both of them have the same phase. This, no, you can understand. See, from here you can understand with the help of graph. Let's say this is the value of, this is the sinusoidal variation of current. This is current. This is the maximum value of current, which is I naught. And from here only, amplitude can be different. So I will suggest if you people have black, blue pens or different colored pens, then prefer it, because for your revision, it will become easier. Why? Because when you will do all the 3 circuits, then you will realize initially it becomes confusing, which is leading which, are both in the same phase. So if you have in this way written, no, I can write it with the help of colorful pens. But for you, if it is possible, if you can have black or blue pens or colored pens, or draw it with a pencil or pen, like this, make combination, so that when you'll revise, you will just see a look and you'll get to know every detail. You'll be able to recall everything. And here also maximum value is E naught. So both are in the same phase right now. This is y-axis, this is your x-axis. Fine, this is the case. Now how to represent it on the phasor? In case of phasor C, if this is E naught, we are just assuming that the magnitude of E naught is greater. This will be I because they are in the same place. Got it? What was meant by it? So I naught is what? I naught, this value, this gap that you are able to see, this is I naught sine omega t, because this angle is omega t. Similarly, this gap that you see, this gap, this is E naught sine omega t. That you can figure it out from the right angle triangle also. This is omega, that how will it will come out to be omega t. This is how we write. This is y-axis, this is x-axis. This is your AC circuit containing only resistor. Fine, class? Just note it down, then we'll see further circuits. Yes, Z, you can leave.
Thank you, ma'am.
Inductor basically means a coil. With the L, inductance. So inductance we have already studied. Now class, AC circuit containing only an inductor. EMF will be what? E naught sine omega t. Fine. And EMF is also equal to one more thing. EMF is also what? Equal to minus L di over dt. This also we are aware of. So from here you can write E naught sine omega t is equal to, you can omit this negative sign because in EMF must be zero. There is no resistance in the circuit. So we are just writing the magnitude. Negative sign you can eliminate because negative sign is given by Lenz's law, and that is just representing the magnitude. So you can eliminate this. You can write it like this. Now what is DI? What is current? Current from here will be E naught divided by L, and integration of what will be left? Sine omega t dt will be left. So again, sine omega t, that will give you cos omega t divided by omega. I will be equal to what? This will be equal to, with a negative sign, minus E naught L. This omega will come. That will become cos omega t. This is clear. E naught by L minus cos omega t. This integration was basically minus cos omega t divided by omega. That's what I've written. This was earlier written already. Now what is left? I is equal to minus E naught by omega L cos omega t. This you can write, this whole term. See, if you compare it with the main equation. This is I naught cos omega t minus I naught cos omega t. From here, this is I naught, this is instead of I naught. So you can easily predict this fact that what? I naught is equal to E naught divided by omega L. And this omega L is written as inductive reactance. This is known as inductive reactance. Before we complete, let's complete this, then we'll move on to what is meant by this capacitive reactance. Or you can write, so this equation is what? This equation is ultimately, if you see, this was what? I is equal to minus I naught cos omega t, or you can see cos theta is actually equal to sine pi by 2 minus theta. So you can write I as I minus I naught sine pi by 2 minus omega t. If you reverse both of these, means if it is minus sine theta, so if you reverse it, that becomes sine minus theta. So both are same. So you can write I as what? I naught sine omega t minus pi by. This is the equation of current. What was the equation of EMF? EMF was simply E naught sine omega t. Now few factors that you have to keep in mind. What was XL? I naught, I told you, I is equal to I naught divided by omega L, which was equal to I naught divided by XL. This XL is equal to omega L. Omega is the angular frequency. And this is the inductance, self-inductance. Now, the resistance, you all know what is meant by resistance. So here, not I naught, sorry, just this will be E naught. So technically, if you see, this is what? V divided by R only. Voltage is here. Instead of resistance, you are having this term. This means what? It is a measure of the effective resistance that is offered by the inductor to the flow of AC. And that is known as the inductive reactance. This inductive reactance, no, this XL, this is known as inductive reactance. In case of resistor, that was resistance, capital R. In case of inductance, when inductor is connected, that becomes inductive reactance. This is XL. And this is what? It's the measure of resistance. It's also a type of resistance only. The resistance that is offered by inductor, that we call as inductive reactance. The resistance that is offered by the resistor, we use it as normal, capital R. Fine. So it's the effective resistance, or you can say opposition also. Offered by the inductor to the flow of AC through it. To the flow of AC through it. This is inductive reactance. So again, inductive reactance is also important because this is unique to the circuit. This wasn't anywhere else, and this won't come again until and unless inductor is involved. This is omega L. Omega can be written as 2 pi nu L, where nu is the normal linear frequency. This is the normal linear frequency. Now, one thing, class, before we, or let's just discuss XL. First, let's complete XL, inductive reactance. See, for XL, no. For AC, alternating current, this XL is directly proportional to frequency, as you can see. So if the graph is plotted, graph is a straight line, graph between XL and the graph between the frequency. Starts from origin, this will be exactly 0. And remember, the value of XL is 0 for DC. Fine, this was all about XL and XL. Now coming back to the main topic, that was inductor. If inductor is connected, are they still in the same phase? So the answer is a big no. Reason? See, equation of current is I naught sine omega t minus pi by 2. And E was E naught sine omega t. It means here pi by 2 is coming extra. So obviously they cannot be in the same phase. One has to lead the other one. You have to compare both of it. If you compare both these equations, here you will find out what? You find that the phase angle of current is pi by 2 radian less than that of EMF minus pi by 2 less than. It means voltage is ahead of current by 90 degree. Current is behind voltage by 90 degree. Pi by 2 is what? 90 degree. Equation of EMF was E naught sine omega t. Here this is coming, but minus pi by 2 additional is coming. It means voltage is leading, voltage is ahead of it. When voltage is ahead of this, so see, if the voltage, remember, always remember this, voltage and current were in the same phase, where in only resistor. Here voltage is ahead of current by 90 degrees. So if I plot the graph, no, this line, graphical line, see, current will be lagging. This will be the graph of the current. This time, this is the current, where it will be having certain maximum value. And EMF, instead of here, EMF will be having its normal value. This is EMF with its maximum value. You can see when it has, see, this is at 0. Here it is lagging by 90 degree. You can see this difference. This is 90 degree. This angle that is formed is 90 degree. This is lagging by pi by 2. Current is lagging by pi by 2. You can see over here. If you have to represent it through the phasor, see if your EMF is here, this is E naught, this is EMF, this is making omega t normal, this is normal. Just a second, give me a second. Yes, class. So EMF is what? EMF is over here. So your current will be lagging behind this time. Remember in resistor, we had drawn this simultaneously together because there wasn't phase difference. Here we are having a phase difference. This time, this will be I naught sine omega t. This is a phase difference. And what is this phase difference? This whole angle is 90 degrees or pi by 2. Fine. This is what is meant by AC circuits having only inductors. Fine, class. So XL you have to remember. Firstly, note it down, then I'll summarize. All of these I'll summarize once. All right, class. Now see, resistor circuit with having only resistor. There you have EMF and current both are in the same phase. None of them is leading the other one. In case of the only inductor circuit, you have the voltage that is ahead of current by 90 degree, and the phase and phasor, the whole graph is like this. So I'll stop here. One last circuit is left that we'll complete on Wednesday only. That is your AC circuit containing only capacitor. When all these three are done, then we'll move on to the numerical. So in the next class, we'll do the numerical. So